Imagine driving alone in a desert no one has ever visited. No roads, no help, no rescue truck. Now imagine your wheels suddenly stop. This is not rare on Mars. Getting stuck is an expected risk. NASA plans for it from the beginning.
Because Mars is unpredictable.
Soil can look solid, but behave like powder.
When a rover stops, NASA doesn't panic.
The first response is suspicion.
Engineers assume something is wrong.
Even if the rover reports no failure.
Data always tells the deeper story. Wheel rotation speeds. Motor strain.
Power usage changes.
Small numbers reveal big problems.
Reading vital signs. Energy levels are optimal, structural integrity confirmed. All parameters are well.
The rover may look fine in photos.
But the data may disagree.
Next, NASA asks the rover to look at itself.
Carefully.
This moment, time stands still. We see the very
Taking images of its wheels. The ground beneath them. And the surrounding terrain. These images travel millions of miles.
Arriving minutes later.
Engineers study every pixel.
Every shadow. Every grain of sand. Is the soil loose or compacted? Are wheels spinning without moving?
Is one wheel deeper than the others?
These details change the strategy.
In one case, wheels dug trenches instead of moving forward. Powdery soil collapsed under weight.
That observation changed everything.
But NASA still doesn't act yet.
First, they recreate Mars on Earth. Full-scale rover wheel replicas. This is accompanied by the rustling of lab coats, footsteps on a hard floor, and the tapping and soft
And soil designed to mimic Mars.
Same angles, same slopes, same problem.
Only after testing does rescue begin.
African-American engineers test every possible wheel movement.
Forward motions.
Backward motions. Slight turns.
Even tiny wiggles. All measured in millimeters.
Because Mars punishes aggressive moves.
Spinning too fast digs deeper holes. Heavy rovers amplify that risk.
Even in lower Martian gravity.
So NASA avoids instinctive solutions.
There is no gunning the engine.
Only controlled, deliberate motion.
Each test run is recorded. Compared against rover limits. Safe operating envelopes displayed.
Motor stress thresholds. System stability. Optimal. Structural safety margins. Nothing is guessed.
Everything is simulated first.
Only then are commands written.
Step 1. Initialize. Step 2. Retrieve component A. Step 3. Align in place. Step 4. Secure and test.
Step 1. Prepare the microphone. Step 2. Synchronize the visual. Because feedback takes time.
Engineers wait, watching numbers.
Did the wheel move?
Did stress increase?
Did the rover tilt?
One successful inch matters.
Progress is measured painfully slowly.
Sometimes it works.
Sometimes nothing changes.
In those cases, NASA stops again.
Stop command executed.
I've analyzed the streams. The previous assessment was flawed, and this data point indicates a critical shift.
And tests new ideas on Earth.
Or even months.
Because haste risks permanent damage.
And Mars offers no repairs. Every rover part must last years.
That constraint shapes every decision.
Including when to stop trying.
Sometimes, rescue is not possible. But the mission doesn't end. Even stuck, a rover can still explore.
Cameras continue scanning the landscape.
Weather sensors keep recording data.
Temperature swings are logged daily.
Radiation detectors never stop counting.
Science doesn't require movement.
In fact, stillness can be useful.
It allows long-duration measurements.
Changes invisible in short visits.
Dust accumulation patterns.
Mars experiences extreme seasonal temperature shifts. When the northern hemisphere tilts towards the atmospheric pressure cycles.
These datasets are rare.
And scientifically valuable.
So NASA redefines success.
From driving distance.
To knowledge gained. A stuck rover still teaches. It becomes a stationary observatory. Watching Mars change over time.
This mindset is intentional.
Built into mission design.
Because failure is expected.
Not as defeat.
But as part of exploration.
Mars is unpredictable. Its soil behaves strangely.
Fine grains act like liquid.
Until weight traps wheels. Earth-tested models can fail.
That gap teaches engineers humility.
And improves future missions. Better wheels.
Smarter autonomy.
Improved hazard detection.
Lessons written in Martian dust. Each stuck rover leaves a legacy.
This is the Spirit rover, nearing the completion of Sol 450. The terrain here in the Columbia Hills is
Opportunity. Each changed how NASA plans.
Perseverance carries those lessons forward.
With caution, hard-earned.
And patience, learned the hard way. Because on Mars, survival is science. A stuck rover changes our definition of rescue. There is no tow truck on Mars.
no astronauts arriving to help.
Rescue happens from Earth, through commands sent as light.
Engineers wait minutes for replies.
Every move must be planned. Carefully.
Beginning with Step 1, the initial assembly. Next, Step 2, connecting the drive components as indicated by the arrows.
And patiently.
Sometimes rescue means letting go.
Accepting limits of technology. And respecting Mars itself. Mars is not hostile. It is simply indifferent. It does not bend to human plans.
Or schedules.
That lesson repeats. Again and again.
Exploration demands acceptance.
We are not sure.
And of patience. Each mission pushes boundaries.
Some pushback.
But all push knowledge forward.
A stuck rover still expands understanding
Of soil.
of climate.
Of engineering limits.
And human decision-making.
Yeah, they allow that it's a separate tier of calipies, and my Jolly says me, so if things found to be done right now.
That is the real rescue.
Saving the mission's purpose.
Even when movement ends.
Look closely at the dust. It tells the story of ages past, moving slowly across my surface.
But relentlessly. Every rover listens. Even when it cannot move. And NASA listens back.
Learning how to explore better.
Step by step. Failure included.
Because Mars allows no shortcuts.
Only progress earned. One lesson at a time.